So for energy, and just a heads up, energy and momentum are usually intertwined. In this particular problem, I'm just going to stick with energy with a little bit of kinematics, but for future reference. So it says the image above shows a block being pulled up the ramp by a motor, and the block rises a total of 5 meters at a constant velocity. Mass of the block is 3, coefficient of the kinetic friction is given as 0.22, the ramp's 30 degrees. So it says, what is the gain in potential energy of the block after it rises the full 5 meters? So the gain in potential energy, that's just going to be mgh, where m is, they give us the mass of the block as 3 kilograms, 9.81 is g, and a height of 5 meters. So 3 by 9.81 by 5 is 147 joules. So 147 joules. Success. B says, what's the work done by friction as the block rises that full 5.0 meters? So work is force times displacement based on some SOHCAHTOA. This is 5 and this is 30 degrees. That means that delta x is 10 meters. You can run SOHCAHTOA yourself, but basically you're looking at the sine of 30 degrees equals 5 over hypotenuse. Hypotenuse is 10. As for the force of friction, this one's going to be a little bit tricky. Remind you, the force of friction equals mu times the normal force. On a ramp like this, here's your normal force, mg, friction's this way, and in this particular case we have tension. The perpendicular direction for the sum of forces would tell us the normal force is going to be equal to mg cosine theta. So the force of friction would be mu mg cosine theta. Therefore, the work done would be mu mg cosine theta delta x. Now, mind you, theta is the angle of 30 degrees here on the ramp. Don't confuse theta thinking that it's this angle here. It is not. So mu is 0.22, m is 3, g is 9.81. We have the cosine of 30 degrees across a displacement of 10. 0.22 by 3 by 9.81. by the cosine of 30 by 10, 56.1 joules done by friction. It says determine the work done on the motor to move the block up the ramp. Well, the motor had to overcome gravity's 147 and friction's 56.1. So since it made it up there at constant velocity, 147 plus 56.1, you got about 203 joules. So the motor's done 203 joules of work. Moving on to D and E, it says it took the block 35 seconds to reach the top. Well, what's the power output? Power is work over time. So 203 over 35. And you'll get a power output of about 5.80 watts. And the final thing, E, is determine the constant velocity of the block moved up the ramp. So it took 35 seconds to move 10 meters. We'll use the overwhelmingly powerful equation. Velocity is the displacement over time. The velocity is the 10 meters over the 35 seconds. 10 over 35, the velocity was 0.286 meters per second. Victory.